Have you ever pondered about the birth of a star? How does this celestial spectacle take place? Let's begin our journey in the vast, cold depths of space, within giant structures known as nebulae. These nebulae are colossal, chilly clouds of gas and dust, seemingly inert but teeming with potential. It's within these nebulae that the stage is set for the birth of a star. Picture turbulence within the nebula. This turbulence stirs the gas and dust, causing pockets of this material to start spinning and slowly rotating. As they spin, these pockets flatten into the shape of a disk. Now the magic really begins to happen. As the disk continues to spin, it starts to condense, to pull together, and to heat up thanks to its own gravitational attraction. Right at the heart of this action, a hot core begins to form. This is the seed from which a star will grow. And grow it does. As the core becomes more massive and compacts further, the temperature rises to incredible levels. When the heat becomes intense enough, a process called nuclear fusion can begin in the core. For the most massive stars, this onset of fusion is like a fanfare announcing their arrival. The star finally emerges from its birth cloud, blowing away the surrounding gases with the intense radiation from the newborn stellar object. This is the birth of a star, an event that occurs countless times across the universe. Yet, despite its frequency, it remains one of the most captivating and awe-inspiring processes in the cosmos. And thus, the birth of a star marks the beginning of a fascinating journey in the cosmos. A journey that will see the star live, transform, and ultimately die, leaving a lasting impact on the universe and providing the raw materials for the next generation of stars to be born. But that's a story for another time. For now, let's marvel at the birth of a star, a testament to the power, beauty, and complexity of the universe we inhabit. So we have a newborn star, but what happens next? What does the life of a star entail? Just as we have different stages of life, so do stars. Once a star is born and nuclear fusion has kickstarted, it enters the most stable period of its life cycle, known as the main sequence stage. Picture this as the star's adulthood, where it has found its rhythm, balancing the pressures of life, or in this case, the pressures of fusion and gravity. At the heart of a star, a remarkable process is taking place. The star's core is the stage where nuclear fusion happens, which is essentially the combination of hydrogen nuclei to form helium. This process doesn't just happen in a flash. It's a dance that takes billions of years to unfold. The energy produced by this fusion creates an outward pressure that counteracts the star's gravitational force, which is trying to pull everything inward. You can think of this as a stellar tug-of-war, with the forces of fusion and gravity perfectly balanced, keeping the star stable. Now you might ask, does a star ever run out of fuel? The answer is yes, but the rate at which this happens depends primarily on the star's mass. Just like a sports car burns through fuel faster than a compact car, more massive stars consume their hydrogen fuel at a much quicker pace than smaller stars. For stars like our own sun, which is considered a medium-sized star, this main sequence stage can last for around 10 billion years. During this time, it maintains a steady brightness and temperature, glowing warmly as it fuses hydrogen into helium in its core. But even stars like us can't remain in their prime forever. As the star uses up its hydrogen fuel, the balance of power in our stellar tug-of-war begins to shift. The inward pull of gravity starts to get the upper hand, causing the star's core to contract. As it contracts, it heats up, and this heat triggers fusion in the layers surrounding the core, causing the star to expand and enter a new phase of its life. During this phase, the star swells into what we call a red giant, its outer layer stretching out into space. Our sun, for instance, will expand so much that it will engulf the inner planets, including Earth. But don't worry, we still have about 5 billion years before that happens. As the star exhausts its hydrogen fuel, it undergoes significant changes, marking the next phase of its life. This is a time of transformation, a time when the star begins to reveal its true colors, literally and figuratively. But that's a story for another time. For now, let's marvel at the journey so far, the journey of a star. What happens when a star runs out of fuel? Does it fade into oblivion or transform into something else entirely? Well, the answer lies in the mass of the star. When most of a star's hydrogen fuel has been consumed in its core, the gravitational forces begin to win out. The core contracts and heats up even further. This extreme heating triggers fusion of progressively heavier elements in layers surrounding the core. Stars like our Sun, which are moderately sized, transform into red giants. As the core contracts, the outer layers of the star expand, making it appear larger and redder. This is a relatively peaceful transformation, albeit a dramatic one. The star swells to many times its original size, its outer layers glowing red. Eventually, the star sheds these outer layers as a planetary nebula, leaving behind a hot core remnant. This remnant, now a white dwarf, will slowly cool over billions of years, fading into the cosmic background. But the fate of more massive stars is much more explosive. These colossal stars undergo increasingly volatile fusion cycles until iron accumulates in their core. Iron fusion, instead of generating energy, consumes it. This depletes the star's source of outward pressure and gravity takes over. The core collapses under its own immense weight in a cataclysmic event known as a supernova explosion. The energy released in a supernova is so vast that for a brief period, a single exploding star can outshine an entire galaxy. The aftermath of this cosmic explosion is intriguing. The core of these massive stars may leave behind an incredibly dense remnant. Depending on the mass of the original star, this could be a neutron star or even a black hole, both of which are fascinating objects with extreme properties that challenge our understanding of physics. Whether they swell into red giants or explode as supernovae, stars undergo dramatic transformations towards the end of their lives. These transformations, from radiant spheres of plasma to exotic stellar remnants, are not only captivating to observe but also crucial in shaping the cosmos. Stars, like all entities, meet their end, but what does the death of a star look like and what remains after? Each star's demise is a grand spectacle unique to its size and composition. Smaller stars akin to our Sun become white dwarfs, their outer layers shed into space, leaving behind a hot, dense core. This core cools over billions of years, eventually dimming into the blackness of space. Larger stars, on the other hand, meet a more dramatic end. Their death throes are marked by a series of explosive fusion reactions, culminating in a brilliant supernova. The star's core collapses under its own weight, leaving behind an incredibly dense remnant, a neutron star. If the star is massive enough, the core collapse is so extreme that it forms a black hole, an entity so dense that not even light can escape its gravitational pull. But the death of a star is not just an end, it's a new beginning. The explosive death of a star scatters elements throughout space. These elements, forged in the heart of a dying star, become the building blocks for new stars, planets, and even life itself. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were born in the fiery furnace of a star's death. So, the death of a star is indeed a spectacle, a cosmic fireworks display, but it's also a critical event in the cosmos. It's a process of recycling and renewal, scattering stardust across the universe, which coalesces to form new celestial bodies. Indeed, even in death, stars continue to shape the universe. They seed the cosmos with the elements necessary for life, contributing to the rich tapestry of the cosmos. Their remnants serve as a testament to their once brilliant existence and a beacon of what's to come. From their death, new life springs forth, continuing the cosmic cycle of birth and death. The life of a star might seem like a distant cosmic event, but did you know it's intimately connected to our existence? Stars are more than just twinkling lights in the night. They are the architects of the cosmos, the alchemists that forge the elements essential for life, from the oxygen we breathe to the iron in our blood. Just imagine each breath we take, every cell in our body, every object we interact with, all contain elements that were once part of a star. Stars, through their birth, life, and death, have sculpted the universe as we know it today. The heavy elements they've created have been scattered across the cosmos, becoming the raw material for new stars, planets, and even life itself. The stellar life cycle is a cosmic recycling process, a cycle of creation and destruction that has shaped our universe and our very existence. So the next time you gaze at the night sky, remember, the stars you see are not just distant lights, they are the architects of the cosmos, and their story is our story too.